My dear JEE 27 2026 warriors, welcome to the 11th standard syllabus everyday live classes at 6 o'clock. And we are on to laws of motion chapter. And today we are going to continue that chapter with non-inertial frames of reference and pseudo force. Okay, so this is a very interesting concept, non-inertial and inertial frames, and concept of a fake force or a pseudo force, and the questions on that. Before this, we have done free body diagrams, different kinds of forces, application of Newton's laws, friction, and all of it. So we are going to go one step ahead. All detailed classes, right from the scratch, we start the concept and take you to PYQs and more complex questions. Yep. Hi, Dilip. Welcome. I do remember you. Hi, Kumukula. Welcome. Hi, Vetri, Mitra, Harshita, Paya. Good evening. Yes, your capto Shreyas Sir is here. And how many of you already registered for MVSAT and excited because you are going to not only see a huge crowd at the centers, but also getting to meet your teachers, lot of goodies, free resources, even after you register, lot of free things are being planned for you, and also there are prizes to be won if you do well in your cohort. Remember, you get to choose which grade, which exam you are preparing for, and you are competing with those set of students, so you know where you stand. All right, so that is what this exam is all about. It's on 4th, 5th, 11th and 12th of October, telling you in advance so that you can be mentally be prepared. And yes, up to 100% scholarship on all our Vedantu courses, guys. So, you have to register using the link which is there in the description box right over here. So, just go down as you're watching the video. First of all, like, guys, and subscribe to the channel in case you haven't done that yet. MVSAT register now. See, this is the link. It's showing everything. Rewards, complete national level ranking with analysis, free courses, learnings or resources, 100% scholarship you can get if you do well, and a pool of 2 crore rupees cash prizes, vouchers, and so many other things. Enter your grade 7th, 8th, 9th, 10th. For every kid, there is an exam. All right, CBSE board, ICSE board, IIT, NEET. All right, your number and your city center. Most of the cities are covered, but if your city is not there, don't worry, we'll try to conduct it online also after this, but register at least now. All right, so let's begin, my dear warriors. Avengers unite. Welcome. Hi, Billy. Oh, waiting for DNA Express. I'm going to see you on Saturday very soon. When you will start the foundation class for IIT? Very soon, Koma Kula. Very, very soon. Okay, it's coming, and I want you to be all ready for it. Okay, so let's begin with the concept of non-inertial and inertial frames of reference. Remember, frame of reference is nothing but a point of view. Is nothing but point of viewing, and it is your choice. It is basically your choice what you are going to choose as the point of view. So I can say that, okay, there is a bus which is moving. There is a bus which is moving. That is my point of view. So that becomes my frame of reference. So this is the bus frame of reference. Then somebody can say, no, 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 for me, the earth which is there. So let's say this is your tree or whatever. The earth is the frame of reference. That means earth as the observer, I'm going to see everything. Why do I need to define this frame of reference? Because motion is relative. This is very, very important. So this choice becomes very, very important, since remember, motion or the concept of rest is a relative term. It depends on the observer. It depends on the observer. For a moving bus, the tree might be at rest, right? But for that same moving bus, a object or luggage, a suitcase inside the bus is at rest, right? So for the moving bus, the tree might be moving with respect to it, but a luggage which is kept inside the bus is at rest. Same way, if you are standing on the ground, the bus is moving for you. the luggage inside it is also moving for you. So obviously motion is relative. Yeah, it depends on the observer. They say, right, beauty lies in the eyes of the beholder. Same way, motion lies in the eyes of the observer. This is by Shreyas. The earlier one was by some beautiful poet, I guess. All right. Hi, Rishwan. Good evening, everyone. Sir, I have exams. It will be a big lose if I miss this week and catch up in the weekend. I'm pretty sure it will be a big loss because this is a very interesting chapter, Abhijit. But hopefully, you will be able to cover up because not much. Two classes of 11, two classes of 12. I think you should be able to manage. But hopefully, you do it very soon. Okay. Now, there are multiple kinds of observers that we have, and we can classify broadly into two categories. One is inertial, and the second one is non-inertial. What do I mean by inertial versus non-inertial? Imagine there is some kind of rock in a distant galaxy somewhere outside our solar system, and some Pandu is on that particular rock. He is the navigator. He is the navigator on that rock. Some distant galaxy. Our Pandu is there over here, and he's moving, floating in space. There is some kind of motion. He's moving in space. Now, these two Pandus discuss with each other whether we are inertial or non-inertial. I'll come to what it is in a bit. Hold on. See, let's say maybe this particular rock which is there over here, it is magnetic in nature, some charges are there on it, some minerals, some ore is there, and some other neutron star, some crazy activity is happening, and there is some force which is being applied on this rock. Maybe there is some kind of net force which is applied on this particular rock because it was some charged body, maybe some ore, some magnetic material was there. Chumma, I'm taking some hypothetical example just to give an idea. The moment there is net force, as per Newton's second law, what should come? As per Newton's second law, what should come? The moment there is a net force, unbalanced force, it should change its momentum. It should accelerate in that direction. So 100% it will accelerate. This rock along with the Pandu is going to accelerate in the exact same direction. Meanwhile, this Pandu asks this Pandu, what are the forces acting on you or the rock? This Pandu is like, see, there are some forces, but maybe they are just cancelling out each other. Okay, maybe they are just cancelling out each other. And I find out that the forces are balanced. That the forces are basically balanced. The forces are basically balanced. That means the net force is zero. In such a situation, by Newton's first law, what should happen? What should happen? It will not accelerate. Therefore, it will be nothing but a uniform motion. It will be nothing but a uniform motion. It will be nothing but uniform motion. That means the acceleration will be a big fat zero. The acceleration will be a big fat zero. So now we have two kinds of observers. One observer following Newton's first law and the other observer following the Newton's second law or the application of Newton's second law. This kind of observer, if you remember, the first law was also called as the law of inertia. A body has a state of inertia. It doesn't change its state until and unless it is acted upon by an unbalanced force. As long as the forces are balanced, it maintains its state. It keeps doing whatever it was doing. So that is the reason why we call this Pandu observer over here as inertial observer. This is inertial observer or inertial frame of reference. As anyways, observer, frame of reference, point of view mean the same thing. So inertial observers are those observers, or inertial frames are those frames which are attached or which are linked to things which are not accelerating, or where basically net unbalanced force is not there. All the forces are balanced. But those observers or those frames which are linked or attached to bodies on which there is an unbalance because of which it accelerates, they are said to be non-inertial in nature. They are said to be non-inertial in nature, or non-inertial observers, non-inertial frames of reference, or whatever you want to call it. Okay, that is how it works. Is this absolutely clear, the difference between an inertial observer or the inertial frame versus non-inertial frame or a non-inertial observer? Okay, acceleration, net force is 0 in inertial. Acceleration is there, net force is there in case of non-inertial frames of reference. So now, if you are going to tell me whether these examples are inertial or non-inertial, okay, in all these particular situations, let's see. Okay, tell me guys, this okay, even before going to this, let's see. Earth. Is Earth an inertial frame? Is Earth inertial in nature? If there is a Pandu observer over here, imagine this Pandu standing somewhere in that continent like this. Is this particular Pandu inertial or non-inertial? Come on, answer in the chat box quickly, all my dear warriors. Yep, think carefully. Answer quickly. What do you think? Earth, sir, Earth, is it accelerating? Acceleration means velocity should change. Oh, so as the Earth goes around the sun, the velocity is changing direction. Oh, it's like a circular motion. So, and even the sun is going around the center of the galaxy. So again, acceleration is there. Oh, definitely there is acceleration because the velocity direction is changing. Earth is also slowing down and again increasing the speed as it goes around the sun. So yes, there is definitely changes in velocity. So it is accelerating. And the moment anything accelerates, that observer becomes non-inertial in nature. Anything which accelerates will become non-inertial in nature. So yes, it will be non-inertial. So this particular Pandu will now be non-inertial in nature. Non-inertial in nature. But if I think a little bit deeply, how quickly is the velocity changing of Earth? Earth is going at 100 kilometers per hour. Now suddenly Earth bent and then Earth again accelerated, vroom, 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 and it started at 200 kilometers per hour. Earth suddenly changed the direction, going east, and Earth suddenly drifting towards the west, and Earth going on the chicane in a very high speed of 500 kilometers per hour. Is that happening? No. It's or else imagine people on the earth will be like this, like this. Oh my God, what is happening to me? Nothing like that is happening. Earth changes the velocity. Earth accelerates, but so slow that we hardly notice it. So that is the reason why, yeah, that is the reason why what? We take Earth for all practical purposes as a inertial frame. So it is actually non-inertial, but for practical purposes. Practically, what do we take as an approximate inertial frame? Approximate inertial frame. This is very, very important. Why Earth is taken as an inertial frame? Because it's not doing these things very suddenly like a jerk or a quick thing which is happening. You don't feel it. Agree? Disagree? Everyone? Yeah? Kopukula, Varthi, Dilip, everyone, Abhijit, yo, perfect. So now think about it. Everything on earth, you are a ground frame. All ground frames will be then inertial. So can we then finally conclude over here that a ground frame of reference. So if you are attaching a frame to the ground, so ground frame, earth frame, ground frame is going to be nothing but inertial in nature. It's an inertial frame in nature for all practical purposes. Imagine from the ground you see some trolley, some bus, some train, some car moving like this, and it is changing the speed. It's accelerating. Will this observer be inertial? Will this observer be inertial? Will this be non-inertial or will this be non-inertial? Think, out of these two people, who is inertial and who is non-inertial observer? They are observing something. Maybe, see, they were both jobless. Both are jobless. See what job they have. This guy is looking at something which is hanging in the trolley. I don't know why it is hanging in the first place. This guy is looking at this dude or looking at that guy, or this Bob, or this guy is looking at that Bob, whatever. Some jobless two people are here. Who is inertial and who is non-inertial? This dude over here is on the earth, on the ground frame. So this particular ground frame will be definitely inertial in nature. Will definitely be inertial in nature. But if you ask me, this dude over here, he's accelerating with the trolley. So 100% non-inertial in nature. Non-inertial in nature. Got it, everyone? As simple as that. Very good. Amazing. Amazing. Yeah. Yes, guys, focus on the class, not among yourselves. Okay. Chatting among yourselves should continue later on. But for now, focus on the class. Yeah. And keep answering. Okay. Tell me about this. Lift is there. It is at rest. Lift is there. It is moving with constant velocity. What kind of examples are these? Inertial or non-inertial? Imagine this dude is over here. This dude is over here looking at something. What do you think this lift frame is? The observer inside the lift, is he inertial or non-inertial? If the lift is at rest, that means for the ground, the lift is at rest. So nothing is accelerating, nothing is having a net force. The tension will be balanced by the weight. Okay, all the forces are balanced. So definitely an inertial observer. It is an inertial observer. What about this lift moving up with constant velocity? Velocity is constant, does not mean it is accelerating. In fact, it means acceleration is zero. So keep this in mind. Velocity is constant, therefore acceleration is zero. So again, it will be inertial frame of reference. Whether going up or going down doesn't matter. This is very important. Constant velocity. Constant velocity. So velocity is constant. So all the forces are balanced. It is uniform motion. Newton's first law. Wherever Newton's first law you see, it is inertial. Non-inertial means second law. Non-inertial means second law. Very good. Yes, perfecto. Amazing. Yep, Dilip, both are inertial. What about this, guys? A lift is accelerating up or lift is accelerating down. If a lift is accelerating, that means the forces are not balanced. One side the force is more, one side the force is less. Okay, so unbalance is there. That is why it is accelerating. It is changing its momentum. So 100% in both these examples, net force is not zero. So acceleration is obviously there. Therefore, both these examples are non-inertial frames of reference. Both this observer here and this observer here, both will consider them to be non-inertial in nature. Yes, perfect. Now, how acceleration is zero? Because velocity is constant, right? If velocity is a constant, then what will be derivative of velocity? It will be derivative of a constant, and dv by dt is nothing but acceleration, right? If there is no change in velocity, it is zero acceleration. All forces are balanced, so it is inertial. It is continuing its state of inertia. If the state is continued, first law, it is inertial. Okay? Non-inertial means it is not maintaining its state because of an unbalance. Unbalance means one side more, one side less. So, it is changing its velocity. Yeah? Yep. Yes, Bhanu, I have covered the entire thing. So, anyways, I'll be teaching it live over here. So, that time also you can watch it. All right. But if you have some test and urgent requirement, watch my road series or even older series, Nurture Pathfinder. Pathfinder, I think it is having it. Now, sir, why do you talk about inertial and non-inertial so much? What is the purpose of this? I'll tell you. See, imagine, okay, let's bring back that rock. Let's bring back that rock. Let's bring back that rock and our amazing Pandu. Okay, amazing Pandu over here. This Pandu and this Pandu. Now, this Pandu, let's say, is accelerating like this. It is accelerating like this. So it is definitely non-inertial frame, non-inertial observer, non-inertial observer. and maybe this Pandu is at rest or moving uniformly. So acceleration of this particular Pandu is 0, or basically you can say uniform motion. Uniform motion. Uniform motion is there. So 100% it will be inertial. 100% that will be inertial observer. What happens is both these Pandus see a champa on the ground, champa on earth, champa on earth or champa on the ground. Okay, say for example, this is our beautiful champa. Okay, so this champa is over here, and both of them are noticing this champa in same champa in two different cases, and they ask champa, what question? What will be their opening line? Will you go out with me? No, that is not their opening line. Their opening line is, what is your free body diagram? Force body diagram. Okay, what are the forces acting on you? That is their pickup line for Champa. So Champa is like, here are the forces on me. One, I'm being pulled by the earth. Very romantic, isn't it? So mg force is there. Mg force is there. And then Champa will be like, also there is a normal force acting on me upwards. There is a normal reaction by the earth on me upwards. Wow, Pandu is super impressed. What a Champa. She answered my physics question. Then Pandus are like, okay, let me see Champa. Normal is there, mg is there. What do I see Champa doing? That's what they also notice. What do I see the Champa doing? If you notice this particular Champa for this Pandu, because this Pandu is not accelerating, this Champa is also on earth. What will be the relative acceleration? Quickly answer in the chat box. What will be the acceleration of Champa with respect to this inertial Pandu? Come on, answer in the chat box, everyone. Nandan, Champa and Pandu, they are our favorite students. They are the most important students who help other students understand everything. Okay, they are our future IITians. No, not every chapter is. Yes, like we said, the batch is starting on 20th August, and whatever chapters are being missed, they will be covered live after October, November. Okay, number one. Number two, whatever chapters are being done, that will be also provided to you recorded. Number two. Number three, not most of the chapters are done. Barely 1/3 of the syllabus is done. Okay, so whatever is done will be given to you live. Okay, cool. Perfect. Yeah. Is this class more than 2 hours? No, no, no. It is barely 1.5 hours. Okay. Now, what will be the relative acceleration of this Pandu? Champa with respect to this Pandu? This Pandu is not accelerating. This Champa is also not accelerating. So relative acceleration is 0. So if you ask me the relative acceleration of the Champa, will be 0 for this particular Pandu. Okay. What about this Pandu when he sees this Champa? This Pandu will think, I am accelerating like this. When he looks at the Champa will appear to move backwards with the same acceleration. So this Champa will have an acceleration, given by A. Will have an acceleration whose value is A. In this case, the acceleration will be itself 0. Oh, interesting. Now Pandu will start thinking, how is this Champa accelerating behind? Because for that Pandu, there is a normal and there is a mg, both are balanced. How can this Champa accelerate? Are you getting my point? This Pandu will never have that doubt, because for that Pandu, this Champa is speaking the absolute truth. Oh, normal is there, mg is there, I don't have any acceleration. So yes, Newton's laws are perfectly valid. As long as the forces are balanced, there should be no acceleration. So over here, if you notice, normal minus mg is equal to 0. Normal minus mg is equal to 0. And in the x direction also, there is no force. This was in the y direction. So if you notice in the x direction, there is no force at all. So there is no acceleration also in the x direction. So as you can see over here, Newton's law of motion is perfectly valid. But over here, the problem is in the x direction, there is no force, but in the x direction, there is some acceleration. That is why this Pandu will think this Champa is lying to me. How is it possible? There is no force, but Champa is accelerating. Here, Newton's laws of motion are not valid. So this clearly tells me in non-inertial frames, what is the problem? Newton's law of motion is not valid. Newton's law of motion is not valid. Is this absolutely clear? Everyone? Yes, very clear. All right. Amazing. Everybody. Oh, so this is a very important conclusion. In non-inertial frame, of reference, Newton's law of motion is invalid. Which Newton's laws are invalid? The first law and the second law, basically. Third law is still valid, is invalid because action reaction is still there, because normal reaction, mg reaction, everything will still be there. It's only the first law and the second law are invalid. This is a big problem. Have you ever noticed that in your school or in your college also, there will be some pet student of the teacher? And if that pet student tells something wrong also, the teacher will be like, no, I think you meant this, right? While answering a question, teacher will, I think you meant this. The student will get, yeah, miss. And then teacher will, what a wonderful explanation. My best student, like this she will do. And what full marks in Viva, or even the paper is being corrected, some spelling mistake, it's okay. One diagram is missing, okay, I'll cut only half mark. One student who is not favorite, even if it has full marks correctly, properly, still you will get 1 mark deduction. Why? I don't know. I just don't like your face. Have you noticed this? Oh, that is me, Nandan. Is that so? You are the pet, huh? Oh, okay. So, in the scientific community, who is the pet scientist? Who is the pet scientist? It is Newton. And if Newton is invalid, will the scientific community like it? They will be like, no, how can Newton be wrong? We have to give grace marks. If you are the pet student and you are failing, teacher will be like, oh, you are getting 30, 35 is needed for passing. I'll give plus additional 6 marks bonus. Chumma I'll give, you will pass, don't worry. You are my pet student. Same way, Newton is our pet student. How can we make Newton fail? So we are like, okay, what to do? Let's identify the problem. We cannot say Newton's law is invalid. Scientific community gathered. Oh, what to do? Oh, this Champa is accelerating. Huh? This Champa is accelerating behind for this Pandu, but there is no force. I got an idea. We'll add a force. But which force? Champa added on the paper, not a real force, just for the sake of it. And we will give it a new name. We will say there is pseudo force acting on this Champa. There is pseudo. Pseudo means fake, not real. Chumma. Okay, this is a Chumma force. It's not real force. And then I can say that there is force in the x direction. Yes, there is pseudo force. And is there acceleration in the x direction? Yes, that is also there. Which is basically A. So now I can say, just like F is equal to mass into acceleration. Yes, definitely. I can say left side also there is something, right hand side also there is something. Earlier, I couldn't write LHS is RHS. F is equal to MA can't be written because F is 0, MA is not 0. How can 0 be equal to non-zero? How can 0 be equal to 5? LHS is 0, RHS is non-zero, not valid. But here, suddenly, we are able to make it valid. Oh, so now, suddenly, under this circumstance, I am able to see that Newton's law of motion is valid. By incorporating a unreal, not true, fake Chumma force called as the pseudo force. So that is the concept of pseudo force, how it was introduced. Okay, it's just introduced to make apply Newton's laws valid in non-inertial frames. In non-inertial frames. For inertial, like Earth, stationary lift, object going at constant speed, no need. But the moment it starts accelerating, if you're sitting on it, if you're sitting on an accelerated body, then you need to incorporate something called as the pseudo force. Yeah, I hope this is absolutely clear. Okay. Yes. Now, where and all do you experience pseudo force? In every situation where there is an acceleration. Have you seen when you are going in a bus or a train, the bus driver suddenly accelerates, you go behind. Who pushed you behind? Who pushed you behind? Tell me. Did somebody come and conductor pushed you? Huh? Your neighbor pushed you, your friend pushed you, nobody pushed you. You just maintained your state of inertia. You feel like somebody pushed. That is pseudo force. The driver suddenly brake. You go and fall on your front person, you get one slap. What are you doing? So, when the driver brakes, again, pseudo force is applied. It's not real. You feel like somebody is applying. It's not a real force. It just gives you that feeling that it is there. So, in every accelerated frame, you will see the application of pseudo force, and it is always opposite to the direction of the acceleration. For example, if this bus is accelerating front, you go behind, force is behind. If the bus is stopping, so the acceleration is behind, you feel the force in the front. If the bus turns to the right, acceleration is towards the right, but you are thrown outwards. So the force which is applied, pseudo, which you feel that it is there, is always opposite to the observer, the accelerated observer's acceleration. Yeah, are you now getting it? Everyone understood this concept? Give me a thumbs up, a fire emoji quickly in the chat box. Quickly in the chat box. So, whenever you have a non-inertial observer, so let me show that observer first over here. You have this non-inertial observer, and let's say the observer itself has some acceleration a, and the observer is observing some kind of a body. This is the body which is being considered. Then you need to show an extra force, which is your FP, which is called as your pseudo force, which always acts opposite to A, where A stands for the observer's acceleration. The value of this pseudo force is very, very important. The magnitude of this pseudo force, that is given by mass into acceleration. But keep this in mind, what is the mass and what is the acceleration? This is the mass of the object or mass of the body being observed. Who are you seeing? Like Pandu was seeing Champa, so it will be Champa's mass. This A is acceleration of the observer, like the Pandu's acceleration. So this will be acceleration of the observer. So this is the magnitude of the pseudo force. Mass into A. But if you look at it vectorially, it will be negative of that, because whatever is the direction of A, it will be exactly opposite of it. So vector wise, if you ask me, it will be nothing but minus of minus of m times of capital A. M times of capital A, that will be the vector equation, but you don't need to remember the vector equation. This is good enough, the magnitude one, m into A. Is this absolutely clear? Minus m into A, that minus you forget it for now. Just think that wherever the observer is accelerating, exactly opposite to that, you will apply the pseudo force. If the observer is going up, pseudo force will be down. If the observer is coming towards you, pseudo force will be back. Okay, that's how it goes. Yeah. All right, perfect. So how do you exactly apply these pseudo force concept in problems? So wherever you see, say for example, some lift is there, okay, and maybe there is some particular person over here, okay, there is some particular person over here, and let's say there is some mass which is kept on this particular lift over here like this. Okay, this is, let's say, m. Okay, this is, let's say, m, and let's say the lift is accelerating upwards. And then we can also take a special case where the lift is accelerating downwards, So in this particular frame of reference, where the lift is either accelerating up or accelerating down, obviously it is non-inertial in nature. So if this Pandu begins to observe anything, this is 100% accelerated. So it is non-inertial observation. So this Pandu frame or the lift frame is non-inertial frame of reference. Okay. Where is this frame accelerating? This first situation is accelerating up. So pseudo force on this box will be down. So this is the direction of the pseudo force. In the second scenario, the lift is accelerating down. So the pseudo force will be basically upwards. If the lift was accelerating right, pseudo force will be left side. If box is accelerating left, pseudo force will be right side. That's all. Keep in mind. Apart from this, other forces will still exist. Like, for example, your normal force will be there and mg will also be there. All these forces will still be there. Same thing over here. Regular forces still show it. Normal will also be there. And what will you see this box doing? The box will be at rest. The box will be basically at rest for the lift frame. Agree or disagree? Quickly put in the chat box. Yes, the box will appear to be at rest. Yes, amazing. Yeah, that feels like Pandu has back pain. Now you just solve the problem normally like you would do. Since it is at rest, that means all the forces must be balanced. All the forces must be definitely balanced. Why balanced? Because you are at rest in that frame. So all the forces must be balanced for each other. So if the forces are balanced, I can definitely say normal is being balanced by mg and one extra pseudo force. In the second scenario, I will say normal is there, and to addition to that, pseudo force is also there upwards. Those two together are balancing mg, which is downwards. What is the value of Fp? We just saw it. The value of pseudo force is mass into acceleration of the observer. So over here, this n is as it is, this mg is as it is. Then we'll see what the value of n is together. Same thing over here also. N is there, and this is mg. So we'll finally get the value of n over here. Okay. Pseudo force is mass being observed, which is small m. So which is small m, into acceleration of the observer, which is basically A in this case. Same situation here. Pseudo force is mass being observed magnitude wise, and acceleration of the observer. Acceleration of the observer is A. Acceleration of the observer is A. Don't put minus MA. It's not needed. Direction is already shown. So don't put minus MA. That is a mistake which many kids do. That's why I told you and I didn't even block this. This was just to tell you the direction concept, but magnitude is very important. Direction, you will show it, no, in the FBD only. You have shown it properly, opposite. Why will you again make it negative? Then you will get a wrong answer. Very good. So in this situation, as you can see, if you shift MA on that side, it will be mg minus MA. M can be taken common. It will be M into G minus A. Whereas in this particular situation, you will see M can be taken common and it will be G plus A. That will be the normal. So this box will experience more normal when the lift is going up as compared to this lift when coming down. The normal experience will be less. And it is also matching with our experiences that you might have shared in a lift. Imagine you are in a lift and suddenly the lift starts going zip up. What will you feel? You will feel heavy. You will feel that as if all the blood in your body is going down. You are maintaining your state of rest. You will feel more heavy. So the normal exerted on you will be more. Because the lift is suddenly going up, you will be pressed down because of inertia. So normal will be higher when it suddenly starts going up or accelerating up. But if lift suddenly starts going down, then you feel as if you are lifting off your feet from the ground. So the normal will be less. It will be M into G minus A. It makes sense. I mean, you can try and recollect from your memory your experiences inside a lift while going up or down, or even in a bus or a car or a joyride, where the joyride is suddenly going up, you feel a lot of pressure on your bum. And when suddenly the free fall effect comes in, you feel a little bit lighter. Yeah, suddenly you feel the floor or the seat is being removed from beneath you. So you feel lighter when it is accelerating down. So it is consistent with our, memory or recollection of our past experiences. Everyone? Face purple crying, manage school and coaching. I have made a separate video, boards, JEE, everything and advanced, how to crack it. I have made a separate video. Please check the video section. Okay. Thank you, Sai. Means a lot, my dear. When I saw PYQ class done by you, I got so much confidence. I'm so glad, Dilip, and more PYQs coming this year. And this year, we'll not repeat those PYQs. We are going to do more. It's going to be JEE Advanced, JEE Mains Plus. This is the ultimate PYQs and problem solving which you will be having. But first, let me complete as much as possible by October, guys. Okay? Right. Okay, perfect. Kavin Raju, why don't you put the comment after the video, guys? You guys don't put comments, and then I feel that you guys are understanding everything. In live chat, you put, I am there to solve your doubts here, but those other off the topic doubts, please put it in the comments. I will reply to your comments. Okay, do that. So let's start solving the questions, guys. That is only the theory. Let's start. A boy is sitting in a moving train. He throws the ball up, and the ball falls behind him. What will the boy think? Oh, okay. Imagine this is the train. Okay, imagine this is the train. This is that particular boy over here. Imagine the train is at rest. If the train is at rest and if the boy throws the ball up, the ball will just go up and it will just come down. It will come at the same place. It will land at the same place. Not just even at rest, even when it is moving uniformly. Even when there is uniform motion, I feel it will land at the same place. Imagine the train is going at 120 kilometers per hour, Vande Bharat Express, you are going in 120 kilometers per hour in a straight line. You might think, sir, if I throw the ball up, will it land behind? How many of you had that doubt? How many of you had that doubt? When the train is going very fast, sir, 120 kilometers per hour, sir, if I jump, will I come back? Will I go into the previous bogie? No, you will still be at the same bogie, same place. So why, sir? I always had this doubt, right? So think what is happening when you are moving with the train. You also have that momentum. You also have that inertia of motion. So both you and the train are already in motion. So when you are jumping, you think you are jumping up, but also you have the forward motion. So that forward motion takes you along with the train and you come back onto the ground. Yes, for the observer on the ground, it might feel like you are jumping forward. For a person standing at a railway station, that person will think, oh, when this person jumped up and came down, the person jumped from the back to the front, but actually the ground below or the floor below, which is the train itself, is moving along with you. So that is why for the train you will land at the same place, but for the ground observer you will land at a new place in the front. Agree? Understood? I hope my voice is fine now. Yeah. Awesome. Awesome. All right, Nohid. Soon I'll be making a roadmap for 28 and 29. Don't worry. If I just refresh, maybe it will be fine. Hi, gaming. Welcome aboard. Uh, the old DNA batch only continues, but V3, remember, this is a express batch, meaning you're still getting live classes, and whatever lectures you missed, we'll be doing it one shot live after the syllabus completes in November, December. Got it? So that way you're not missing on any live content for any chapter. Number two, whatever classes you missed, you are still going to get the recordings of it. Got it? Because what happens is many times students cover the entire syllabus in one shot. At least now you have that opportunity. Okay, whatever syllabus is there, 1/3 is being done, 2/3 is there, that I'm doing it properly in detail, and whatever is left, that much part only you are doing one shot live. Understanding it? That is the most effective way. Great. Awesome. Now imagine the situation where this train is accelerating, and this same Pandu will launch that ball in air. What will happen, guys? I don't think it will land at the same place. I think it will land somewhere over here. Why is that so? Because you're accelerating in this frame. That means there must be what? A pseudo force. Pseudo force. P silent. So pseudo force will be there. That is the reason why it will fall behind. So in this particular question, the ball falls behind of him. That means the train is having some kind of acceleration. So answer C is the most appropriate answer. Got it, everyone? Give me a thumbs up. Clearo? Yep. Oh, I see this question in Tattva book also. Very nice. And Tattva books are amazing. Just Ragul, go with the flow of level 1, level 2, level 3, level 4. Okay. But don't solve all the problems. Go with the topic flow. I mean, today if I'm teaching pseudo forces, only solve those questions of pseudo force. Level 1, level 2, level 3, level 4. And go with the theory topics which are given in Tattva. They are beautifully written down. Nice notes are there. And then go to the level 1, level 2. Level 3, see if you can do it. Level 4, see if you can do it. If you can't do it now, it's okay. You can leave it for now. Okay. But at least level 1 and 2, try to do 60-70% of the questions. That is good enough. Level 3, 1-2 questions, 3 questions. Level 4, 1-2 questions. Good enough. Okay. Later on in revision phase, you can slowly start doing more and more. Thank you, Gayatri, for all the love. Saipriya, you are very, very late, my dear. I don't know why everybody is joining in late today. I was seeing at 6 o'clock, suddenly very few people are waiting. I was wondering what happened. Did my kids disappear somewhere? Yeah. Okay. Hello, everyone. Yeah, thank you so much. What is the name of the series? The name of the series is Nameless. Okay, we don't believe in such things every single time. Sir, what series are you starting? So many YouTube channels. Sir, we are starting this series. How long did it continue? 5 days, 5 weeks. After that, new series. Again, from the scratch. Again, new series. That is the truth of so many other YouTube channels. You go and see. Okay. But you see on Vedantu JEE English, whatever we tell you, we'll do it. If we are going to do important chapters only, we'll tell you from before. We'll not chumma say, oh, we'll complete everything and not do all these things. Nonsense. Okay. Cool. Now, oh, like Roar series, it is not given any name. I didn't think of any name for this series. We just thought we'll just do daily live classes. Just go with the flow. Sometimes that is the best thing to do, I feel. Anyways, a lift is moving with acceleration. A man in the lift drops the ball inside the lift. The acceleration of the ball as observed by the man in the lift and a man standing outside on the ground. This guy is non-inertial. This guy is inertial. Very interesting question, guys. Let's see if you guys can answer this. Amazing question. Tell me, for the ground observer, okay, for the ground observer, this is basically ground observation, which is obviously inertial in nature. if you draw the free body diagram of the ball, there is only one force on it, and that singular force is mg, nothing else. The ball is not touching anything, no force of tension, spring, normal, some miracle force, nothing is there. Pseudo will not come in inertial. So whatever acceleration it will have, if you write F is equal to mass into acceleration, force is mg, m into a, therefore acceleration will be g, cancels. So for the ground observer, for the man standing on the ground, the acceleration will be g. Now g is there here also, g is there here also, g is there here also. So B option is out. Either it is A, C or D. Either it is A, C or D. Now what do we do for the next part? For this dude over here who is non-inertial, which is the lift frame, which is basically the lift observer, 100% it is non-inertial in nature. Non-inertial in nature. Now, if you draw the free body diagram of that ball, what kind of forces are there on that particular ball? Think about it. One mg is there, and because you are non-inertial, there must be a pseudo force. Lift is accelerating down, so pseudo force will be upwards. So pseudo force will be upwards. And finally, some acceleration over here with respect to the lift. Okay, how much it is, I do not know. I will just call it A with respect to the lift. Here, in this case, if I apply Newton's law now, I'm allowed because I'm taking pseudo force. F is equal to mass into acceleration. That force here will be mg minus Fp, will be mass into acceleration with respect to the lift. How much is the pseudo force? It will be m into A, mass of the body into acceleration of the frame or the observer. So this will be m into Al. M cancels. So what is Al? It is going to be G minus A. It is going to be G minus A. Where is G minus A, guys? G minus A is right over here. So option C is the most appropriate answer. This is very interesting to see how for the lift frame, I mean, the acceleration scene will be very different. And for the lift frame, apart from the original weight, the pseudo force will also be there, which is exactly opposite to the observer's acceleration. So observer's acceleration is down, so pseudo is up. So net force is MA. Net force is bigger force minus smaller. Why this is big? Because the ball is going down. So this should be big, this should be small. So big minus small is the net force, is mass into the acceleration. M cancels and we get the answer. Understood now, everyone? मेरा गेट का कोई बैच नहीं था अंकित. There was no batch for gate. Okay, and guys, if you have forgotten to like the video, please like the video right away right now, because many students chumma keep watching and then they realize, oh, we had to like the video. Please do that. All right, let's go to the next question coming up on your screen. There is a person who weighs 80 kg, person whose weight is 80 kg on a weighing machine in a lift that is moving upwards with some acceleration. What will be the reading on the machine? Actual mass is 80 kg. The person is standing on the weighing machine, but the problem is the entire arrangement is going up at 5 meters per second square. That is the problem. No issue, Sai. I think sometimes you will have to watch it recorded. That's okay. Hi, Pritija. See you back. Like already. Thank you so much. Will there be no normal force? Ragul, in the previous question, no normal force. Why? The ball is floating, falling in air. No, it is not hitting the ground yet. After it hits, or if it was resting on the ground, then it was a different story. Now it is falling, accelerating. That is the reason why no normal has been shown. We are used to drawing normal every time. So, MG normal. Think first. So that is why be careful. Okay. So if you ask me to draw the free body diagram of that person from the lift perspective, so the lift frame of reference is non-inertial in nature. So I've shown the frame of reference. Now let me draw the object under consideration. This is our dude who weighs 80 kilos and is standing on the weighing machine. What are the different forces, dude? So this dude says, listen, bro, I have mg force. M is 80. So 80 g force, which is basically the weight of the person, the gravitational pull. Then there is a normal force. The normal is basically, the normal on the person by the surface below. The surface below is the weighing machine. So normal on the person by the weighing machine. That is what it is. Okay. One last thing. Yes, there is no relative motion. So it is at rest 100%. And pseudo force. How can we forget pseudo force? Lift is accelerating up. The frame is accelerating up. So pseudo force must be downwards. So Fp, magnitude will be mass of the observed quantity into acceleration of the observer, the lift, which is 5. So 85 za, 85 za, 40. So 400 newtons. Okay. Now, since you are at rest, that clearly tells that the forces are balanced in nature. The forces are balanced in nature. The forces are balanced in nature. Okay. What is the upward force? It is normal. What is the downward force? It is 80g as well as that pseudo force which is there. Okay, sir. So let me show what is 80g. 80g means 80 into 10. G is 10. So this will be 800. And pseudo is nothing but 400. So what is the value of normal I am getting? 80 plus 40 or 8 plus 4 is 12. So this will be 1200 newtons. 1200 newtons. Everyone till this point absolutely clear? Now, whatever normal is exerted on the person is also the normal exerted on the machine. So if you draw the free body diagram of the weighing machine, if this is our weighing machine, if you draw the weighing machine, on the weighing machine, the force which will be exerted from the above will be the normal force. So it will detect that force and it will give me exactly that same reading. So the reading will be of 1200 Newton or basically 120 G, or it will feel as if the apparent weight is 120 kilogram. It feels as if the person is weighing 120 kg. The person will be very sad when he sees his reading. My God, weighing 120 kg? But actually his mass is 80 kg. Just that the lift is going up, so additional pseudo force creates that apparent. Apparent means it is not actual, it feels like. So it feels like you are 120 kg over here. Is that absolutely clear? So 1200 Newton or basically 120 kg. Is that clear? Yep. Oh, it's not about this lecture. Pritija, if it is not about this lecture, can you put it up in the comments after the video and I'll definitely answer it. But if you feel that it is something which you want to hear from me, then ask me near the end of the class. I will definitely answer it. Okay. Fine. Let's do the next question, my dear students. Here it comes. Here in this particular diagram, there is a pendulum which is suspended from the roof of a car that has a constant acceleration. As seen from the ground observer. So this dude sees this car is moving with some acceleration and there is a pendulum which is hanging from the ceiling. What do you think will the pendulum do? It will move back. How? Let me demonstrate this to you. So imagine my charger is only the pendulum. This charger is the pendulum. Now the car, that is me, imagine, is at rest. So the pendulum is vertical. Now imagine I start to move in the front. Observe carefully. The moment I start to move in the front, what happened? Immediately the pendulum swings back. And if I continuously accelerate, just observe it again, okay? Probably you'll have to watch this video at 0.25x or something. As soon as I go front, the pendulum swings back. So the moment you accelerate in the front direction, the pendulum goes behind. If you accelerate this side, the pendulum goes this side. So if you just look at the pendulum, you can guess whether the driver is accelerating, braking, or moving uniformly. How many of you realize this? How many of you realize this? Hi, Kevin. Welcome. Yeah. Every rest body, relative rest body will be balance force. Yes, correct. How many of you realize this? Yeah. So looking just the angle of the pendulum, you can immediately guess whether the trolley is accelerating or not accelerating and in which direction also. So cool. Question is, what is that angle? Question is, what exactly is that particular angle? Okay, what is that angle? All right, not a big deal. First, let's look from the observer over here. What will he see? The observer inside the particular train. The observer inside that particular train frame of reference. So the train frame or whatever, what is it? Car, is it? Roof of a car. Okay. So car frame of reference obviously is non-inertial, in nature. So when we try and draw the free body diagram of this bob, okay, this is the vertical, this is the horizontal, okay. So the forces acting on it are, obviously its own weight will be there. It is suspended in the air, normal will not be there, but the string is there. So along that direction, there will be definitely a tension force. And because it is non-inertial, so acceleration is this way. So pseudo force will be the exact opposite way. So on this ball, the pseudo force will be in this direction. Everybody understanding this concept? Okay, very good. How much angle is this? We can figure it out because the pendulum makes an angle theta. So think like this, guys. The pendulum is making an angle theta with the vertical line and the bob is over here. The ball or that bob is over here. These are basically two parallel lines, and this is an intercept. So if this angle is theta, it's natural that this angle is also going to be theta. Alternate angles. So 100% this angle is also going to be theta. Okay. So now it makes sense to actually split the tension because that is the only force at a weird direction, to split it into two directions. One component like this, which will be away from theta, that will be T sine theta. The one which will be closer to theta, close C for cos, C for close. So T cos theta. So what I have done is basically I have broken down the tension force. That tension force which was there, I have split it into two components. Okay, I have broken down that tension force into two components. And of course, this entire thing is going to be at rest. Why is it going to be at rest? Think carefully again. If I am the observer inside this car, when this pendulum comes behind, for me, the pendulum is at rest. Just think about it. For you, it is moving, but for me, the pendulum is at rest. Is this absolutely clear? Yeah? Okay. Yes. Amazing. Amazing. So, therefore, the forces are going to be balanced. The forces are going to be balanced. Amazing. So that means upward force, downward force balanced, leftward force, rightward force also balanced. Demonic, you are going to see me on Saturday. Saturday, my lecture is scheduled. Sorry, not Saturday, tomorrow. What is tomorrow? Thursday. All right. So Thursday, my class is there. You are seeing me tomorrow. Okay. Yep. And also, I am taking few chapters and PNJ sir is taking few chapters already mentioned in the Sigma or DNA batch, whatever videos I had made, already mentioned. PNJ sir is there with me in the Sigma batch. He is also an IITian. Okay. All right. Fine, Bhanu. I'll make a week by week schedule also. Okay. Now, upward force is how much? And down left right force is how much? Let's see. As you can see, left right force T sine theta should be balanced by the pseudo force. Pseudo force is mass being observed into acceleration of the observer. So that is basically T sine of theta. In the upward downward direction, tensions cos theta is being balanced by mg. So therefore, that's it. I mean, I don't have to do anything. That's it. Okay. I got these two equations. It makes sense to divide both of them. So divide both these equations. So t sine theta by t cos theta will be ma by mg. Sine theta by cos theta is tan theta. Tt cancels, cancels. You will have a by g. That's it. Therefore, theta will be tan inverse of a by g. That is the answer. So the angle made, we have got it. Tan inverse of a by g. So if acceleration is more, theta is more. If acceleration is 0, theta is also going to be 0. Everyone clear about this? Awesome. Perfecto. Clearo. Understoodo. Great, great. So this is how you apply pseudo force into concepts. So most of the questions are like this only, okay, where you have to draw the usual forces, show the pseudo force, see whether it is moving, accelerating, like in this previous example. Where did it go? In this previous example, it was accelerating, but most of the examples, it will be at rest only. So all the forces just chumma get balanced, okay? Great. So let's go to another amazing question coming up on your screen. Beautiful question. There is a block of small m which is at rest on another wedge of some mass. The angle of the wedge is theta. The wedge is given some acceleration such that the mass m falls freely. What is the minimum value of a? So that the mass m will fall freely. There could be one more question which could be framed on this. There could be one more question which could be framed on this, such that this m instead of falling freely, let's say it is given the mass m stays at rest relative to the wedge. Both these kind of questions can be made on this. Now let me tell you, this question is very simple, stays at rest relative to the wedge, whereas this one, so that this mass m falls freely, is more trickier one. Let's do this one so that you get an idea of it, and then I can show you the other one as well. Okay. Sir, another method without pseudo force. Okay, I'll show you another method also without pseudo force for the previous one if you want to. It's not that difficult. See, if you just take probably the ground observer, na, then it is nothing. There is only mg force which is there, and then there is tension force. But that tension also, I can split it up as two components, T sine theta and you will write T cos theta. And then this ball will appear to move for the ground observer with some acceleration. So if you look in the y direction, T cos and mg will balance. T cos theta will be equal to mg. Basically, they balance each other, or you can just say T cos theta minus mg is equal to mass into no acceleration. Therefore, T cos theta will be equal to mg. Similarly, if you look in the x direction, there is only one force, which is T sine theta. So T sine theta will be mass into the acceleration. If you notice, this is exactly the same equation which you are getting over here. T cos is mg, T sine is ma. T cos is mg, T sine is ma. So you will anyways still get the same answer. Theta is tan inverse of a by g. So when you are in the ground frame, basically, then you don't show pseudo force. You will see the body accelerate. So you will write force is ma. That's all. So automatically it is taken care of. Is that okay, Tejas Surya? Perfect. Now going to this particular question right over here, the block should stay at rest on this particular wedge. So what should be the acceleration given to the wedge? See, imagine some object is there okay, on an inclined plane. If you leave that object, and the surface is smooth, the object is just going to fall down. Now, if I move this behind, if I move this surface behind, then also it will fall down. But imagine I push it like this. Just observe, okay? See how this will right now slip versus if I move it in the front, how it is staying there until I stop. See, when I'm moving it, it is staying there. When I stop, again it falls. So if I move it just enough, I should not move it too fast. If I move it fast, then again it will fall down. Is it? Yeah. So I have to move it exactly the appropriate amount so that it stays there. That is the concept over here. So what I will do, I will make the wedge as my frame and look at the box kept on it. All right. So if I take that box which is there over here, what are the different forces acting on it? One is obviously its own weight, and next one is its normal. That's it. So normal is there, its own weight is there, and my frame of reference, my observing frame is nothing but the wedge itself. Now the wedge is accelerated, so 100% it is non-inertial in nature. It is non-inertial in nature. So I have to push the wedge, I have to push it like this so that it stays there. I have to accelerate it by some amount. So the wedge itself is accelerating by some amount this way. So there must be a pseudo force on the block like this. Do you guys understand why the pseudo force is in this particular direction? Everybody, I am pushing the wedge like this on the horizontal surface, so the block stays on it relatively as it is. Okay. So what's the value of this pseudo force? It is mass of object being observed into acceleration of the observer. So m into a. Three forces, and it should be relatively at rest. It should be at rest. Great. So I will try to balance the forces now. I can see normal is at an angle. I don't like it. So I'm just going to split the normal into two components. How do I do that? Okay, here it is. This is vertical, horizontal lines. If this angle is theta, it means this particular angle is also theta. If this is theta, this angle is also going to be theta, the same angle of the wedge, right? This is the wedge plane. This is horizontal. This is theta. This will be ignored. This will be then theta. This will be ignored. Then this will be theta. This will be ignored, and this will be theta. That's how the angles will go. You divide into 8 parts. Every alternate angle will be theta. Kind of makes sense to split normal into 2 parts. So one component will be here. It's far away from theta. This component is closer. So this will be n cos theta, and this will be nothing but n sine of theta. Because it is at rest, obviously things should be balanced. Things should be balanced. Okay. So in x direction separately we will take, and in y direction separately we can take. Okay. So in x direction separately, y direction separately, we'll try to balance everything. So in x direction, I can see MA is being balanced by n sine theta, and in y direction, I can see n cos theta is being balanced by your mg force. Mg force is balancing mg. Mg force is balancing n cos theta. That's it. Two equations. I think we need to divide them. So let's see what happens when you exactly divide these equations. So you will have MA by MG is equal to n sine theta divided by n cos theta. MM cancels, so we will have A by G is equal to sine by cos, which is tan of theta. Therefore, A will be nothing but G tan of theta. A will be nothing but G tan of theta. Yes. So hence in this options nothing will match, but the answer would be you will accelerate the wedge. How much will be the acceleration of the wedge so that the block stays as it is? The answer will be G tan theta. Everybody got this point? Everybody got this point? Forget these options over here. Yeah, amazing. Clear? Give me a thumbs up, guys. Give me a thumbs up. Now you will start asking, sir, what if you take the original question, what is the acceleration so that the mass m just fall down freely? It should just fall down freely. Yeah, it should just fall down freely. If this mass m falls down freely, what does it mean? What are the forces acting on that mass? Tell me, guys. If you consider that particular mass, and it should fall down freely, free fall motion is there. Free fall motion is there. That means the acceleration is just going to be g. That means the only force that can bother it is nothing but none other than mg. Nothing else can bother it. Only mg force is there on it. Normal force is absent. There is no contact only. There is no contact only. So it is just coming down with g acceleration. Oh, the box is coming down with g. So how can I figure out the wedge's acceleration? Now that is something which I leave to the next class. Why? Because we are going to learn something called as the constrained motion and multiple pulley systems. That part can be easily done with the constrained motion concept. So keep that in mind. We will be doing this exact same question, and that is why this question becomes slightly more trickier. Getting it? Okay. Yes. So that is why that question had minimum word on it for this particular question. But for this question, there is no need of using that word minimum. Then just one unique value will be there of acceleration. There is no need of that word minimum. Okay. You will need exactly this much acceleration to keep the block at rest relative to the wedge. But when you will have to let it fall freely, then you will need to pull it at a different rate and there will be some minimum acceleration. Okay? Is this absolutely clear, everyone? Why this problem now goes to a different zone? Here, this problem is simple, but when you look at minimum value of acceleration so that this falls freely, then there is some kind of relationship which you need to find between the accelerations of the block and the wedge, and that is something which we'll be doing in the next class, not now. Okay, so how much is the acceleration of the wedge? That is what is being asked. Okay, so we'll find that in the next class, not in this class. All right. But now for this particular sake, let's say we have solved this question where you found out how much you are accelerating the wedge so that this block stays there as it is, but both of them are moving together. There is a question which comes based on that, and it looks something like this. Look at it over here. Find the mass capital M so that this system moves together and it prevents the smaller block from slipping over the triangular block. What a question, guys. What a question. You are attaching some mass here. Every surface is smooth. If you do not attach any mass, then this mass will just slide down. It will also push the wedge behind. That's another story. But you have connected a string here, attached a mass. So this mass is pulling that string. This string is pulling this wedge. But you have to put enough mass so that this wedge moves enough so that this mass is not falling down. If you attach too less mass, then it will move very slowly and this mass will come down. If you attach too much mass, then it will pull the wedge very fast and this mass will go behind and topple from on the top. Okay, so you have to attach exactly some mass so that this mass moves with this wedge over here. That is the question. Now tell me one thing. Forget this mass, this pulley and this string. If you forget that, this diagram, does it look very similar to this diagram? Does it look very similar to this diagram? Yes or no? And in this problem, did we figure out the same scenario where this block stays at rest with respect to the triangular block? And we figured out how much the acceleration should be? Yes or no? So now tell me one thing, this exact same question, if you focus only on this much part, we already know the answer, for how much should the acceleration be? How much should this wedge accelerate by? And that acceleration, we figured it out to be g tan theta. We figured out to be g tan theta. Solved before. This was nothing but your previous question. This is nothing but your previous question. That part is needed for this question. If you don't solve that question, you can't solve this question. That is why some problems build up onto another problem, and using this problem, you can build up one more question like that. Oh, sir, then what? What do you do with this? Okay, I'll tell you what. If you take this as one system, then what is the net external force? Then what is the net external force, my dear warriors? In the horizontal direction, there is only one force externally, and that is tension. If you consider this entire system whose total mass is m plus m prime. So using Newton's law, net force is mass into acceleration in the x direction. I can say the only force over here is the tension. The mass is m plus m prime, and acceleration is nothing but g tan of theta. Oh, so we get the value of the tension. We just got the value of the tension. Oh, amazing. What do I do with it? Go down over here. See what are the forces on this. Same string, same tension. There will be additional capital mg weight, and this will be also going down with the exact same acceleration. Oh, now we are getting onto something. If you draw the FBD, which we have done, and now again write net force is mass multiplied by acceleration, but this time in the vertical direction. Mg is bigger than T because it is going down. So Mg minus T is equal to mass into the acceleration. Okay, but I already know the value of tension. What is the value of tension? We figured it out over here only. It was nothing but m plus m prime into g tan of theta, okay, is equal to capital M into A. Capital M into A. A I already know. It is nothing but g tan of theta. Oh, wonderful. And what was the question? Question is find the mass capital M. Find the mass capital M. That means you have to find this capital M mass. So divide it with g tan theta. Divide it with g tan theta. Okay. So the moment you divide it with g tan theta, see what will happen. M will be there. G will cancel. So by tan theta minus, here you will still have that m plus m prime, but since g tan theta is divided, nothing will stay over here. So this is the mass, guys. M will be m by tan theta. So if you want, you can just write this as m is equal to, oh, but wait a minute, this m is also here, so we need to shift it now. Okay, so m, I can just shift it here and bring this guy over here. So m cot theta minus m is equal to m cot theta minus m is equal to, this will be m plus m prime. This will be m plus m prime. So taking m common, what am I left with? Cot theta minus 1. So cot theta minus 1 will come below. Cot theta minus 1 will come below. And on the top, I'm still left with m plus m prime. M plus m prime. What a brilliant question, isn't it? So m, three masses are there. So if you make a mistake in the symbol, gone. Yeah, you will make a blunder, you will get silly, negative marks, or you'll lose marks already. Yeah. So be very, very careful in which m's you are using where. So this acceleration was g tan theta, which we got over here. Obviously, if this goes this much, this will also go by the same much. So acceleration magnitudes were same. So we use that and we rearrange the equation to get it in a beautiful form. Yeah, that would be the answer to this particular question. Yeah, it is almost the same thing. Yeah, whatever we have done. Yeah, say this, m plus m prime cot theta minus 1. Okay, got it, my dear students? Everybody with me? Everybody with me? Understood? Clear? Shall we go ahead? Super easy. Now it feels easy. Okay, but if you solve this question, then it is easy because you have already done this micro concept. So that is what you need to do in JEE. You have solved so many questions that it becomes easy for you. Okay, now let's see whether you can figure out this answer. Okay, so find the deformation in the spring kind of question, or basically find the extension in the spring. Forget this question. I would say forget this question inside the left for a moment. Just forget this. Just forget the spring even exists. Forget this lift also exists for a moment. And just tell me this answer first. This pulley is being supported by a roof. Can you figure out how much force is there between this string, between the pulley and the roof? How much force is there? Okay, can you figure that out? If you can figure that out, then it becomes an easy problem. That pulley is there. It is being supported by the roof over here. There is some string which is wrapped over it, which is connecting the blocks like that. We know there will be some kind of tension over here, some kind of tension over here, and there will be some kind of force from the top. Can you just tell me how much that force will be? First, let's solve that, then we can go ahead. Yes, T and T together, because this entire thing, pulley, is at rest right now. So equilibrium is there. So definitely that force will be 2 times of T. But if you remember my previous class, where sir, previous class? It is there here only, bro. Yo, come here, man. What are these people? Some dog and all is coming. How do I go? Oh, okay. If you go to the channel and go to the live, or even go to the home page, and yeah, all the past live streams are there. Or 12th and 11th syllabus is separate. Go to my physics playlist of 11th. You can see all the lectures are arranged beautifully. So over here, where is it? Newton's law, friction, FBD pulley. This particular lecture, we have solved this question. It was a big 3-hour class. So you can see all our classes are in detail. We are not doing one chapter in 3 hours. Many channels are doing that. One chapter in 3 hours. Yes, it's good for revision, but not for studying in the first go. So if you open this class, we have done the exact same question. Yeah, how much was the answer for this? We have solved that pulley related question somewhere here. I don't remember. If you remember it, guys, tell me the answer quickly in the chat box. See, we are doing pulley questions and all of that over here. Yes, what is the answer? What is the value for the tension? 2m1. See, the same problem, pulley problem we have done. 2m1 m2 g by m1 plus m2. Wow, this is so slow, huh? 2m1 m2 g by m1 plus m2. I'm telling you the answer. Now I don't have that patience to load it. So it is 2 times m1 m2 by m1 plus m2, the whole thing into g. Oh, is that so? So therefore, that particular force will be 4m1 m2 by m1 plus m2 into g. Amazing. So that is if entire thing is at rest. But now the catch is it's in a lift which, oops, sorry. It is in a lift which is accelerating upwards. Okay. It is in a lift which is accelerating upwards. 1 second. It is in a lift which is accelerating upwards. Okay. We'll deal one problem at a time. For now, let's get rid of that spring. I don't care. Yeah. Get lost, man. Okay. If you just think about this particular element now, how much will be the force in this element if this entire setup was in a lift? The difference will be exactly only in G. Still 4m1 m2 by m1 plus m2 will be there. Instead of G, what will now come? Think. Instead of G, what will come now? Because it is in a lift. Lift is going up. everything will feel more weight, heavier. Instead of G, you will feel G plus A. Instead of G, you will feel G plus A. The same question which we solved here. This box in a lift going up, normal is no longer mg, it is mg plus a. Lift was going down, then it will be mg minus a. So wherever g comes, either it is g plus a or g minus a. Oh, is that so? The lift is going up, I will feel heavier. So instead of g, now it will be g plus a. Simple. Till this point, absolutely clear? Oh, yes, sir. What now, sir? There is one thing remaining. Spring, sir, spring. Don't worry, man. The spring is experiencing some spring force. So whatever is that spring force will be kx. Oh, that's it, sir. Yes, bro. So just put the value of the force 4m1 m2 by m1 plus m2 into g plus a is equal to kx. So x will be 4m1 m2 by m1 plus m2, that k came down and that g plus a stayed on the top. That's the answer. Looks so complex, but solution is so easy if you break down the problem into simpler steps. What did I do? The moment this question was given, I'm like, to hell with the spring and to hell with the lift. I said, get lost. Okay. Then it looked like a simple question which I already know. So always look for that part of the problem which you know and build up on that problem like we did in the previous question. This problem I know, and over there we know acceleration and tension. And in that I needed to think extra. Oh yes, if these two tensions are there, the force which will the exerted by the roof will be 2T. Oh, T I know 2m1 m2 by m1 plus m2. That formula you should know. Or else then again you have to draw FBD, solve it. Again lengthy it will become. So this part, tension is this much. This you should know because you have, yeah, see we have done this over here. Yeah, this you should know because you have already done the question in different chapters or in different solved examples, whatever it is. Okay, so that is very, very important, guys. And from there, I said if lift comes, G will be replaced by G plus A. If spring is there, that force which is there will be Kx. So force I know, Kx equal K, bring it down, that is the answer. Amazing. Loved the question, guys. Very good, very good, very good. Amazing. So that was the question which we just solved, and that was the last question. And I hope you understood the concept of pseudo force, inertial frames and non-inertial frames. So you will see most of these questions will always involve lift or a moving trolley. Sometimes block on block questions can come. Yeah, that will become JEE Advanced. I will solve it again very soon. Okay, where we solve mixed concept questions and everything. But today I hope you understood what is pseudo force, what is inertial frame, why you apply pseudo force, why Newton's laws are not valid in non-inertial frame, and what is this concept of apparent weight, when to use G plus A, when to use G minus A, and how Newton's laws of FBD, all of this is again useful in every single question. You cannot say that I studied there, I will forget it. Yeah. So this was your Captain Shreyas, and I was going live on Vedantu JEE English, the #1 JEE English channel in the country. Yeah. So stay subscribed. If you're not yet subscribed, please do that and like the video, share it with your friends, this channel, this video. Talk about Shreyas Sir, talk about your captain who is leading the ship in this rough sea, because next year the paper is going to be difficult and you need my guidance. Having done that for the past 13 years, let's do this one more year, guys. You need to put in your effort. And if you're a 2027 student, then I'm going to be with you for the next 2 years, right? So be there, consistent on the channel, like every video, share this channel, talk about this channel in your college, school. Also comment below with the answers to the homework question, if any. Today's homework was not there, but today I have left one problem unattended, if you remember. So that problem, if you want to solve it and still give the answer, you can still give it. Answer will be should be posted in the comments. Okay, all the very best, my dear warriors, and take care. Bye bye Naveen, Dilip, bye bye Sai Priya, bye bye Vetri, bye bye Abhijit. Studies, yeah, thank you so much, thank you so much. I'm so glad you guys loved it. Yeah. Naveen, I took your name too. Yes. Okay. Take care, guys. Bye bye. Hasta la vista. Signing off.